Hi, and thanks for watching this instructional video for CSCI 1300. In this video, we will cover the basics of using pseudocode and how to implement it to describe an algorithm. Pseudocode is meant to communicate algorithms using precise English that describes what a program does. It is meant to communicate algorithms without all the extra mental overhead of getting the details right in any particular programming language. So in the prompts that we have here, we're trying to do a interest type of problem or a banking type of problem. And the problem states you put $10,000 into a bank account that earns 5% interest per year. How many years does it take for the account balance to double the original? Well, the first thing I would do is I would say, okay, what's the desired output? The desired output is what number of years, how many years does it take for the balance of the account to reach $20,000 or twice the base amount, which is $10,000. So in this example, we need to come up with some pseudocode. So let's come up with pseudocode that is more English defined than it is code defined. Now, I do want to remind you that pseudocode is flexible and the exact wording is not important. What is important is that pseudocode describes a sequence of steps that is unambiguous, so it is very clear to everyone that reads it. It is executable, so something can happen every time that it is performed. And terminating, meaning that eventually the process will conclude and you will get some results, some output, some solution to your problem. So if we think about this problem, let's try coming up with a loose, generalized form of the pseudocode. And then we'll try and take this and make it a little bit more code syntax-like to get it a little bit closer to a programming language. So the first thing I would do is I would say, like, well, I think that we should probably start with a beginning year, and we'll have to compute interest, and we'll probably have to input the beginning balance. And then there's probably going to be some repetition that will be involved until we reach some termination. So let's just say that the first step would be to start with a year value of 0, considering that we wouldn't consider a year until it was completed. So we're going to start with a year value of 0, and at the end of 12 months we'll have completed 1 year of interest being applied to the account. We're going to have a column for interest to keep track of how much we have to add to the balance every year, and an initial balance of $10,000. So our input here, if we define our input, our input will be to have $10,000 as a starting or base amount in the account. And let's see, we're going to then repeat the following steps while the balance is less than double the original amount, which would be $20,000. So let's see here. Step 1 would be to add 1 year to the year value. So that means that we're going to increase the count of the year by 1. And then what we're going to do is we are going to compute the interest as balance. So that means that we're going to take the balance, actually we're going to take it as the balance of the account multiplied by 5% in decimal form. So this would give us 5% of the current year's balance. And then we'd have to add the interest calculated to balance of the account. And we're going to continue to do this every year until we reach $20,000. And so that final part would be when we report the final year value as the answer to our problem. So we're going to continue this series of steps until we get a final number of years it took to finish the whole task. And this is a basic way of doing pseudocode. It's very general. It's written in plain English, and it's broken up into a series of steps or a recipe that you can follow. And once you write it this way, you can now go back and make it more syntax correct for your code that you'll be working in. So if we try to formalize the pseudocode to be more like code syntax, let's get it a little bit closer to what we're looking for. Well, we're going to have some variable probably to keep track of the year. So we'll have to declare that, and you know what, let's set it to year 0, because we're going to start with a 0 year just like before in our original generalized pseudocode. And we know that we're going to have a variable to keep track of the balance of the account. That balance is going to be initialized to $10,000. And let's do some kind of a repetitive process. So I'm going to write a loop. So while the balance is less than 20,000, so while we still haven't reached $20,000 in our variable for balance, we're going to take the year, just like before. This is our step 1, and we're going to add to that year by 1. And we do need to compute the interest, so that means that we'll have to have a variable for interest. And we'll have to take the balance that we have started with and multiply that by 5%. And that'll be stored in the interest variable. So we'll keep that separate from balance until we're ready to add it in the next step. So in this step, that's what I'm doing. I'm going to take what we just calculated and I'm going to add it to the balance repetitively until we reach $20,000. So we take $10,000, and then on the first year it looks like we'll get $500, and we'll keep adding incrementally to that amount. So at the end of the first year we should have $10,500, which will become the new base balance for the next year. And once we're done, we will output whatever the year variable contains. So that's really what we're trying to return, is the year variable. And that, I think that we've covered everything to terminate our process at this point, and we've written it in 2 ways. That's all for writing pseudocode for algorithms in this video. Thanks for watching, and happy coding!